Welcome back inside Unreal Engine for filmmakers. In this masterclass, you will know how to integrate your footage with 3D scenarios using Nuke and Unreal Engine. In this video, I will show you the chroma key process inside the complete version of Nuke. In this case, I already created the clean plate, as you saw in the last video. In this case, I put the denoise in the beginning of my workflow, and I think it's a little bit better, but I don't see a lot of changes in the final results. Now we have to create our soft key, our core key, and our garbage matte. In this case, I will start with the soft key process, using the keylight node and another node that will help us to create a better selection of our subject. This node is called OCIO color space. The OCIO color space is a node similar to the color space transform inside DaVinci. Using this node, I will do the keylight operation inside a specific color space. Let's go inside the property panel of the OCIO color space and let's change the input transform. In this case, I need to set my input transform in ACES 2065. And the output node, I set the composition log. As you can see now, my sequence is converted in composition log. Now I have to duplicate my OCIO color space node to convert the composition log back to ACES 2065. So let's duplicate and let's switch the input and output of my node. Be sure to work inside the correct OCIO color space. Okay, now we restored the original color space of our sequence. Now I will add the keylight node between the OCIO color space nodes. Perfect. Now let's visualize our keylight. And now I will pick the green color of my composition log sequence. Perfect. As you can see, we made a really good soft light selection. In this case, you don't have to adjust the clip black and the clip white. This is a perfect soft matte. Now let's create a new point between the screen clean and the OCIO color. Let's adjust a little bit the structure, okay. Now let's add the new node for our core matte structure. I will use one of the premium node of Nuke, in this case the PriMatte. The PriMatte tool is a really powerful node. With this node we can create a really good core matte without losing details, also in the most complex areas like the hair of our subject. Inside the PriMatte property, we can check the operation of our node. In this case, I have to select the background color, so let's click on the black rectangle and pick the green. In this case, we create a really good starting point for our core matte using the PriMatte tool. We can create a better result using the clean background noise and the clean foreground noise. With the clean background noise, we can pick again our background in order to make a better selection of our background. In this case, the PriMatte tool made a perfect job just using the default selection. But we can use the clean foreground noise to make a better selection of our subject. As you can see, some areas in the shoes are not perfectly white. So let's press Ctrl on our keyboard and let's paint the area that we want to preserve on our chroma key process. Okay. Let's check our timeline. The PriMatte made a really good job. Now I want to soft the edges of my PriMatte. To do that, I have to add a new node called Erode. With the Erode node, we can expand or shrink our selection. As you can see now, increasing the value, I'm shrinking the image, decreasing the erode filter, I'm expand the selection. Now, pressing B on our keyboard, we can add a blur node. I'm using the blur node to soft my selection. Now I can merge the result of my soft key with my core matte selection. Let's create a new merge node and connect the A input to the blur node and the B input to our OCIO color space. Perfect. As you can see now, we merge the pre-matte operation with the key light operation. Now we can create the garbage matte. In this case, I will show you another method to create a garbage matte in a more simple way. Let's create a new point after the pre-matte and let's add a new erode filter node. Let's connect our erode filter to our line. And now let's expand our selection. Expanding my selection, I create a first garbage matte for my subject. Now I have to create a mask to include only my subject inside the garbage matte process. So let's add a roto node. You can quickly add a roto node pressing O on your keyboard. Instead of the Bezier, in this case, I will use the rectangle tool. Let's select our subject. And now let's track our mask. Pressing Shift and moving one of the corner of my selection, I can also change the side of my rectangle. Now we have to combine our rotonode mask and our filter road node. To do that, we can create a merge node and change the operation to stencil. Let's connect the A input to our roto node and the B input to our filter road node. In this case, my subject was eliminated by my mask selection. I can quickly fix this operation by changing the alpha of my mask. Now we have to combine our two merge nodes. We will create another merge node, but we will set the operation to in. Let's connect the B input to our stencil merge node and the A input to our over merge node. Perfect. Perfect. Now we combine our core matte, our soft matte, and our garbage mask. As you can see, we achieve a really similar result to our Nuke non-commercial chroma key process. Now let's add our copy node, pressing K on our keyboard. Let's connect the A input to our merge node, and let's add our PXF kill spill node to despill our image. Our despill is correct, and now we can connect the B input of our copy node to the PXF kill spill node. Let's add the pre-multiply node. Okay, perfect. And this is our result. As you can see, we have a giant edge around our subject. To fix that, we have to adjust some node of our chroma key process. In this case, probably I have to adjust my erode filter node. So let's open the property panel and change the size value. I suggest you also to check the blur node and change a little bit. Okay, let's reduce the blur. Okay. I can do some adjustment in the filter node. Okay, also in the blur. Okay, I think this is a really good result. So finally, we complete our chroma key process. Let's see a before and after of our result. As you can see, we achieve a really, really nice chroma key result. The edges of my selection are really smooth and really, really realistic. In this case, for the final output, I don't see a lot of difference between this chroma key and the chroma key with Nuke Non-Commercial. In the next lessons, I will show you how the PrimeMat tool can be a game changer for some types of footage. For example, if you want to preserve the fine details of the air. Now we can also add the edge extend node. And as you can see, we improve much more our chroma key process. But I remember that the edge extend tool is not a perfect tool. Sometimes you will get also some glitch and some bad result inside your process. So I recommend you to check the entire timeline when you're using the edge extend tool. Now you know how to chroma key your footage inside Nuke Non-Commercial and the complete version of Nuke. I will continue to show you the journey inside Nuke using the non-commercial version. But if you are using the complete version of Nuke, you can follow the same steps that I will show you inside Nuke non-commercial. Welcome back inside Unreal Engine for Filmmakers. In this masterclass, you will know how to integrate your footage with 3D scenarios using Nuke and Unreal Engine. Once we complete our chroma key process, we can start with the camera tracking. The camera track process is the same between the free version of Nuke and the premium version of Nuke. So let's start with duplicate our read node 1. I will copy here. Now we have to connect our read node 1 to the camera track node. So let's press on tab and let's search camera track 3D Classic. As you can see on the right, we have the property panel of the camera track. And now we go to the setting page and let's check preview features. Now in the viewport, we can see the point that our camera track will analyze to track the sequence. But there is a problem. As you can see, there are some points also on our subject, and we don't want to track the subject movement because they will not respect the camera movement. And analyzing also these points, we will achieve a bad camera track. Our subject from our 3D camera track, we can use the Rodo node that we created in the chroma key process. So let's duplicate it and let's create a merge node. Okay, now I will deactivate also the RGB channel on the output. And let's drag our merge node between the read node and the camera track. Now we can return on the camera settings properties and on the camera tracker tab on mask, let's choose source alpha. In this way, we exclude all the elements inside our Rodo node. And as you can see, our subject is obviously inside the Rodo. But as you can see, there are also one other person that can damage our camera track. In order to exclude him, we can create another mask using the same Rodo node. So let's create our mask around him. In this case, you don't have fear to lose some tracking point because this area is not the most important area to track of our sequence. Okay, great. And now let's track our mask. You don't have to do in this case a really precise track. As you can see, we don't have so much track point around him, so it's not a problem. Be a little imprecise with the track of our mask. Perfect. As you can see, also inside the other mask, we don't have track point to analyze. Now let's return on our camera track node. And from this tab, we can finally start with our track. Don't worry if you don't set the right film back size or the right focal length. Nuke will analyze the sequence and will generate a 3D camera with almost the same focal length of your footage. Obviously, if you have this information, it's okay to specify inside the property of our camera tracker tab. In this case, I prefer to don't set the right film back and the focal length because I want to show you how this tool can work also without these informations. If you want to do some tests, I can say that this shot was filmed with a 14mm on a Canon C400. Now let's press on track. And our camera tracker will analyze our footage. So let's wait until the complete of this process. After the tracking process, we have to solve our camera track. As you can see now, we have an error value in our camera tracking properties. In this case, we have a value of 2.21. In order to achieve a good camera track, we have to decrease this value to 1. To achieve that, we have some possibilities. The first is go inside the Auto Track tab, and changing these values, we can change the tolerance of our camera track selection. I can change the minimal length for each track and also change the max track error and the max error. I suggest you to decrease this value step by step in order to see what we will achieve every time you will change them. So let's decrease our max track error. Let's try something around 5, for example. And also we can decrease a little bit our max track error. And as you can see, some track point will be red. Those tracks will be removed from our camera track analyze. In order to remove them, we can click on Delete Rejected. We can turn back with this operation, so if you will delete these tracks, you can't restore them without retrack from scratch the sequence. Deleting these tracks, as you can see, the solve error now is become lower. Now let's decrease again our max track error and our max error. I suggest you also to don't push so much those values because we need the track point in order to create a good camera track, and decreasing too much this value will be also delete a lot of camera track points. So let's find a good value between number of pointed tracks and solve value. Now let's delete our track point again. Okay, 1.41. Let's decrease again our max track error and our max error. Okay. I suggest you also to check all the timeline in order to understand how much track point we are deleting. In this case, I have a lot of track in the ending of my sequence, so I don't have fear to delete more tracks. So let's press delete rejected. And now we achieve a value of 1.17. This is a really good result. For me, it's okay, but we can try to decrease this value. Let's start with the user tracks. The user tracks are some tracks that we can choose from our viewport in order to create a sort of priority for our camera track. We have to choose the best track point in order to help our camera tracker to create a better track. So in this case, I will choose some track point around the tracker that we put on our set. In this case, I can verify better the behavior of my trackers. Let's selecting using Shift. And now let's click on one of them. And in the little window that we open, let's press on track and extract user track. In this way, we give a priority for our camera tracker based on this tracker that we selected. Looking at the viewport, I can also see that we have two bad point of track because we can verify the precision of this point of track because there are no contrast around them position. So let's press on track and delete trackers. Now let's go back on our camera tracker homepage tab and let's press on solve. As you can see, we decrease our value to 1.1. Now we achieve a perfect camera track, but we have another method to try to decrease this value a little bit. In case you have few point of track in your scenario, or you really need to decrease the solve value, we can use custom trackers. With custom trackers, we will create some point of track in our scenario manually in order to help our camera tracker node. In this case, I will create a custom track on this area because I have a really good contrast between the background and the black frame. So let's press on tab on our node graph and let's find tracker. Now let's connect our tracker to our read node. And as you can see, on top of the viewport, we have this new bar for our custom tracker point. Let's start on the add track to add another track inside of our viewport and press on the pixel that we want to track in our sequence. Great. In this case, I will also change the size of my track rectangle. Changing them side, now the area of our camera track will be smaller than before. Now we can start with our custom track, clicking on track to the end on our top bar. In this way, our tracker will analyze the footage from this frame until the last frame of my sequence. Now let's wait until the end of our tracker progress. As you can see, the position of our tracker changed a little bit during the track. It's not a problem in this case, but if you want to create a better result, we can find the first frame that our tracker start to lose its position. So let's go back until the best track point that we achieve. In this case, this is okay. And now let's press on clear forward. In this way, we deleted all the track point of our custom track, but now we can restart with our track to end in order to create a better camera track. Great, now we have to track all the sequence before of our first track point. Now let's return to the first frame we track and let's press track to start. And now our tracker will be analyze all the sequence from the last frame. I don't so much happy about the result, so let's find the best tracker that we track before, and now let's press on clear backward. Now let's reactivate the track to start. Okay, it's a little bit better. I can consider this custom track okay. We can also manage our custom track position frame by frame. In this case, I can also move the position of the current track that I can see in my viewport. As you can see, I can simply move the position of my track point. Great. Now I will create more tracks for my read node. As you can see now, I connect 6 custom trackers to my read node. Now I want to add these tracks to my camera tracker node. To do that, we have simply add these tracks inside the user tracks tab. So let's go inside the properties of our camera track node, user tracks, and now I can click on import trackers. Now I have to choose the custom trackers that I created. And as you can see, I have my custom tracker inside my user track tab. Now I will add all the trackers that I created. Once you complete this process, now you can solve your camera tracker node. Let's see the result. In this case, we achieve a worse result than before. That's because some custom trackers are not enough precise. But I'm sure that the tracker 15, 18, 19 and 20 are really precise. So I can remove the other tracks from my user tracks tab. Now selecting the user track 2 and user track 3, I can delete them from the user tracks tab. Let's solve again our camera track. Now we achieve a solve value of 1.09. As you can see, is a little bit better than before, nothing special. And I can say that the custom trackers don't improve so much my camera track process, but in some case, with also an handheld camera, the custom trackers are essential to achieve a really good 3D camera inside of Nuke. So now let's create our 3D camera. Activate the new 3D beta and after click on create. As you can see, a new node appears inside of our node graph. This is the 3D camera. Let's click on our node and after let's press tab inside our viewport. And as you can see, we have the 3D visualization of the 3D space of Nuke. Now let's close all the properties. And as you can see, closing the camera and the camera tracker node, I can see the 3D camera and the tracker point inside of my viewport. So let's open again our nodes. And now as you can see, the visualization is really compressed. This is only a problem about the visualization and not about the camera track. To fix that, we can go inside the properties of our camera track node, go to Scene, and let's change the scale from 1 to 100. Now we can see really better our 3D viewport and the movement of our camera. But as you can see, the movement of our 3D camera begins under the 3D floor of Nuke. Now we have to fix that in order to achieve a 3D camera that match exactly with the real camera position. To achieve that, we have to specify inside of Nuke what tracks are positioned on the floor of our footage. So let's press on tab inside of our viewport to return to our footage visualization. And now, for example, at this point of my sequence, I will select some trackers on the floor. So let's try with this. I suggest you to don't add so much trackers. In this case, 6, 7 tracks is okay. Now, right click, ground plane and set to selected. Now the colors of our tracker shift to purple, and on the 3D viewport, we can see that the position of these tracks matched with the floor of the 3D viewport of Nuke, and the movement of our 3D camera now match really better with the footage. But now we can verify if our 3D camera match exactly with the real camera, but we can verify this adding some tracks inside of our graph. So let's go inside our 3D viewport, clicking on tab, and let's add a card node. As you can see now, if we zoom in inside of our viewport, a 2D card now appears inside of our viewport. Now, inside the property panel, let's change the rotation to create a card that match with the floor. Now let's scale also. I will set the scale of my plane based on the position of my trackers. Okay, let's add a little bit. Okay. As we can see, the position of the card match with the 3D floor position by default. And now I will duplicate my card node to create a 3D wall inside of my 3D viewport. So let's duplicate it, and if you double click on this node, you can also activate the gizmo inside the 3D viewport. Now let's change the rotation of our node. Okay, now we have the wall of our 3D scene. Now I will try to match the position of my 2D plane with the last track point of my 3D viewport. Something like that. Okay, let's change the Z position. Now I have to create a material for my 2D planes. So let's add a new node called checkboard, and let's connect the cards node to our checkboard. And now we have to connect our cards to our 3D camera. To do that, we can add a new node called scene. Let's connect our cards to our scene. Okay. And now let's add another node called Scanline Render. Let's connect the cam input to our camera and the OBJ scans to our scene. I will reorganize a little bit my node graph. Now, in order to verify our 3D camera, I want to connect my Scanline Render to my read node. To do that, I can simply use a merge node. Let's connect the A input to our Scanline Render. And let's connect our B input to our read node. Now let's visualize our merge node. And now I have my read node and my Scanline Render in the same viewport. And increasing the mixed value of the merge node properties, I can also see my sequence. And now I can finally verify the movement of my 3D camera inside my real footage. As you can see, the position of my 2D floor plane is like that match with the floor position, and also the position of my wall match with the wall of my green screen space. If you have some doubts, I will suggest you to change the mix value in order to see better our footage and our planes. In this case, I will also change the scale of the floor card node in order to see better the point of contact between our floor and our wall. In this case, the 3D floor and the 3D wall match perfectly with the real footage. But let's suppose that I want to improve the match between the footage and the 3D scene. To do that, we can go in the Scene tab of the Camera Tracker property node and change the translation and the rotation. In this case, I think that my 3D camera match perfectly, so I will create some random changes inside of my viewport. Maybe we can think that our 3D camera match with our real footage. But if we play our viewport, as you can see, the movements of the two cameras don't match at all. And I'm sure about that because it's like my subject is levitating inside of my 3D scene. In this case, changing the translation and the rotation of my camera tracker node, I create a bad matching between my cameras. But sometimes you will need to change these values in order to achieve a good matching. Now I will restore the default values of my translation rotation. And if I play again inside of my viewport, as you can see, we match perfectly the 3D camera with the real footage. It's like the 2D plane is anchored to my real floor. So now we are ready to export our 3D camera from new. But I will not only export my 3D camera, but I will export also a 3D card that match with my 3D floor. So let's add a new node called GeoCard. Now let's press tab inside of our viewport to see the 3D scene. And now I have to match the scale and the position of my GeoCard to the card node positioned on the floor of my 3D scene. In this case, I can see my card node because I have to change the rotation of my node, and also I have to connect the GeoCard to my checkboard. In this way, we will connect a material to our GeoCard. And now if we double click on our GeoCard, we can see our GeoCard inside of our viewport. Don't worry about this glitch effect, it's caused by our GeoCard match perfectly with our card node. And we want that. So in case your GeoCard doesn't match with the card node, you can simply copy the translation values of the card node to the GeoCard node. You don't need also to change the scale of our GeoCard node. This size is perfect, and you can also change the size inside of Unreal. Now let's add a new node called GeoScene. And let's connect our GeoScene to our GeoCard and to our 3D camera. Now this node have the information of the geo card and the camera 1 node. And now we can finally export our geoscene using a node called GeoExport. But before to export our geoscene, we have to scale the translation values of our 3D camera. We have to do that because Nuke and Unreal use different unit of measures, and scaling the translation values of our camera, we will create a perfect match between camera movement inside of Nuke and camera movement inside of Unreal. So let's open the properties of our camera node and let's click on this icon on the translation values. Press on Edit Expression, and now you have to multiply per 10 the X, Y, and the Z. So let's add per 10, and per 10. Okay. Now we change the scale value of our translation inside of Nuke, and this will create a wrong camera inside of 3D viewport of Nuke. But don't worry, inside of Unreal, we will achieve the same result of our 3D camera that we see before. Now we can finally set our GeoExport node. So let's open our GeoExport, and using the properties of the GeoExport node, we want to export a USD file from Nuke. So let's choose USD, and let's choose the directory of our USD file. In this case, I will create also a new folder. Let's call it USD, let's press OK. And now let's set the output name of our USD file. In this case, I will call it camera3d.usd. Remember that you must type also the extension of your file in order to export it. So let's press OK. And now we can press on Execute to create our USD file. From this panel, we can set the first and the last frame of our export. Be sure that these values match with the duration of our read node, and also deactivate Continue on Error. Now you can press OK, and once your render is complete, you can finally open Unreal Engine. Welcome back inside Unreal Engine for filmmakers. In this masterclass, you will know how to integrate your footage with 3D scenarios using Nuke and Unreal Engine. Welcome back inside of Unreal. In this case, I'm using Unreal Engine 5.5, and I downloaded the Dark Ruins Megascan sample environment. Below this video, you have all the information to download Unreal Engine 5.5 and this environment. Before to start, we have to add some plugins inside of our project. So let's go on the plugin tab and let's search USD importer. We need this plugin to import our 3D camera from Nuke inside of Unreal. Now let's search Media Plate plugin. This one. We will use the Media Plate to see our preview sequence inside of Unreal. Let's search also Movie Render Queue additional render passes. With these plugins, we can add more information and data inside of our render in EXR, and that will help us in the composite process inside of Nuke. The last plugin that we want to add inside of our project is the OCIO Open Color AO. With this plugin, we can export from Unreal EXR sequences in ACES in order to match our sequence with our real footage inside of Nuke. In this case, obviously, I will not add these plugins because I already added inside of my project. And once you restart your project, you can finally begin to work inside of Unreal. Before to start, I want to explain you better how this environment works. This environment have a lot of exposure variation inside of it. So in order to adjust the exposure in each area, this environment is full of post-process volume located in a specific areas of the 3D scene. And as you can see, if I move far my camera, now my viewport is really underexposed. That's because I'm no more inside of the post-process volume of the beach area. And also, if I go inside the cave, I will move from the beach post-process volume from the interior cave of my process volume. As you can see, if I enter inside of the cave, my exposure will increase inside of the cave. And through this method, I can see in a proper way the interior of the cave. Now let's return out of the cave and let's add our 3D camera from Nuke. So open the Window tab and open the USD Stage Editor. From the USD Stage Editor, I can import my camera, pressing on File, Open, and this is our 3D camera exported from Nuke. So press Open, and as you can see, we have our geocard, the material of the geocard, and our 3D camera. Now let's press on Actions, Import. Now we have to choose the directory of our 3D camera. I suggest you to create a folder called USD and press OK. Click Import and close the Stage Editor. The first time you will import a 3D camera from the USD Stage Editor, you have also to choose a directory for the USD cache. Don't worry about it, you can choose whatever directory you want. I suggest you to create a folder called USD cache to locate it in an organized way. Now let's open our USD folder. In my case, I have all the USD camera that I imported inside of this project, but you can see a folder called Camera 3D. This folder has the same name of our USD file, and inside of it, we have 3 folders. In the level sequence folder, we have obviously our level sequence with the animation of our camera. We have the material of the geocard. Ariel will import a black material for the geocard, but don't worry, we don't need a material for our geocard. And last, we have a static mesh folder with the geocard inside of it. As I said you in the previous video, we will use this geocard to match the floor of our 3D camera movement to the floor of Unreal. If you don't see the camera, don't worry. When you import from the USD Stage Editor, we will import all the assets inside of our outliner. So inside of the outliner, let's find our Camera 3D file. As you can see, we have this blueprint file, and inside of it, we have another blueprint that contains the Camera 3D and the geocard that we imported before. In this case, I suggest you to rename your 3D camera. In this case, I will call it UFF_tutorial camera. And now, lock our Camera 1 blueprint and our 3D camera. So right click on our mouse, let's find transform, activate locked actor movement. I'm doing this because if I move my camera inside of Unreal, I will lose the track, and the only way to restore it is to restart again with the USD stage importer. Every time we import the USD inside of Unreal from the USD stage editor, we have also to modify the position of the Camera 3D blueprint, because by default all the axes will be positioned in the 0 of our environment. In this case, I know that I want to create my render from Unreal in the upper zone of my cave. So let's move it inside the viewport and find the right place that we want to position our 3D camera. Okay, I will choose this bridge. By default, this bridge is not good, as you can see in my video. I achieved this result simply using the same asset 3D and positioned over the bridge. In my case, I downloaded an asset from the Fab Store, but you can use these static meshes that by default are located inside your content browser. You can use only one static mesh and duplicate it for the whole bridge. Now we have to snap the position of our Camera 3D to our view. So right click on our Camera 3D in the outliner and click on Snap Object to View. Now my Camera 3D blueprint is in the same position of my view inside of my viewport. Now I will change my position, and as you can see, this gizmo represent the position of my blueprint. Now, inside of our content browser, let's open our level sequence. And inside of it, we have our 3D camera and the blueprint that contains our camera. In this case, I will change the name of my camera also inside my level sequence. So UFF underscore tutorial camera. In order to work in a more easy way, I will add another viewport inside of my project. So in Window, click on Viewport and press on Viewport 2. We will use this viewport to see our UFF tutorial camera. And now I can move my blueprint in my Viewport 1 and see the changes of my 3D camera. But as you can see, we can click on our blueprint and see the gizmo inside the viewport, but we can't see our geocard. That's because in Unreal the geocard is a plane, and inside of Unreal the plane have one side transparent and one side with the material. And if we rotate our viewport, we can see our geocard. To rotate our geocard, let's activate the snap tool and rotate by 180 degrees our geocard. Now I will adjust the position of my blueprint to match the geocard to my ground. Before to start, we have also to lock our geocard in order to don't lose our reference for the floor. So transform, lock actor movement, and now we can move the position of our camera 3D blueprint. So let's move it inside of our environment. And let's match the position of our geocard to the floor of our bridge. In this case, I have also to fix the rotation of my 2D plane. So press E on your keyboard to activate the rotation gizmo, deactivate the snaps on rotation, and let's match the rotation of our geocard to our bridge. Now, I can change the position of my blueprint to set the position that I want to achieve for my render. In this case, I want that my camera see the opposite side of the bridge. So let's rotate our camera 3D blueprint. Perfect. I think that this is the final position that I want to achieve. We can see our geocard that represent the original floor of our 3D camera. But now I need to have a preview of my final composite inside of Unreal. To do that, we have to add inside of our project the MP4 preview that we exported from DaVinci in the first lesson of the video. You can download it in the folder below this video. So let's go in the content browser. And let's create a new folder inside the Camera 3D folder. I will call it this folder footage. And let's drag inside of it our MP4 video. Now to add our video inside of the viewport, we can simply drag this file media source inside of our environment. This is a media plate, and clicking on this icon on the details, we can see a preview of our video. But before to start, we have to create a proper material to contain our video. So let's create a new material inside of our content browser. And I will call this material mm_chroma key material. Perfect. Now we have to add a media player inside of our content browser. So let's find media, media player, and activate video output media texture asset. Let's press OK, and let's give a name to our media player. In this case, I will call it virtual production. And now we have also a material texture with the same name of our media player. Now let's open our media player and let's find our file media source. In my case, I have a lot of file media source inside of my project, but you will have only a single video that you imported before. Now double click on our MP4 video, press save and close the media player. As our media texture is linked to our media player, we have also the video inside of our media texture. Now we have to set our material. Let's open the master material and set our material to a mask blend mode and to an unlit shading model. In this way, our material will not be affected by the lighting of the environment. Now let's drag our material texture inside of the material graph and let's connect the RGB output to our emissive color. And let's connect the alpha to the opacity mask. As you can see now, our material contains the media texture and the video that we imported before. Save, close it, and let's create a material instance. In this case, I will call it ME Chroma Key Material 1. 1 because maybe I want to create other material instance inside of my project in the future. Now let's drag our material instance to our media plate. But as you can see, our media plate is completely black. This is a problem of this environment that is really exposed, so it's normal to see the media plate black by default. In fact, if we check our directional light inside the outliner, we can see that the intensity of our directional light is really high. So it's normal that a normal material with an emissive color set to 1 can look completely black. So we have to adjust our master material. As you know, to increase the emission of our material, we can simply use a multiply node. So let's find a multiply node inside of our graph. And let's connect the A input to our media texture. And let's connect the output of the multiply to the emissive color input of the material domain. Now let's create a new scalar parameter that I will call it brightness. Let's set it to 1. And let's connect the parameter to our B input of our multiply node. Now save the master material, close it. Let's open our material instance. And now we can activate the scalar parameter and try to increase this value. And setting this value to 250, now we can start to see our media plate. In my case, I will increase this value around 1000. And now I can see in a really good way my media plate. And now we can save our material instance. But now, in order to see in a proper way my sequence inside of my environment, I want to eliminate the green inside of the media plate. To do that, we have to modify again our master material. So let's open the master material and let's create a new node called MF Chroma Key. Now let's connect the input color of our chroma key to our multiply, and let's connect the emissive color output to the emissive color input of our material domain. And let's connect also the opacity output to the opacity mask input. Now we can save it, and I also suggest you to set the texture sample to a parameter in order to modify the media texture inside of the material instance. In my case, I will call my new texture parameter preview video. Okay, let's save it, close it. And now let's open again our material instance. Now we have to adjust the operation of our chroma keyer node. So let's activate the key color and pressing on the key color box. And now we can use our color picker and pick the green of our set on the media texture icon. Don't worry if you see the material instance completely white, it's simply because we set a really high value for the brightness. You can also set your brightness to 1 inside of the material instance and reset the correct value of the brightness before to save it. And as you can see, we eliminated the green color from our media plate. But now we have to anchor our media plate to our 3D camera. In fact, if we move our 3D camera, as you can see, the media plate is in a fixed position. And also we have to activate the video of our media plate, because if we remove our camera, the video is completely locked in a static frame. So let's drag our media plate from the outliner to the level sequence. Let's press on yes to deactivate the autoplay of our media plate. Now right click on our media plate timeline, properties, and on media source, choose the media player video that we imported before. In my case, it's a little bit more complicated because I have a lot of video inside of my project. And on media texture, let's select the media texture that we created before. In this case, virtual production video. Okay. And now our media plate is animated inside of the level sequence. Now we have to anchor the position of our media plate to our 3D camera. To do that is really simple. We can simply click on the plus icon on our media plate inside the level sequence, attach, and select our camera. Now let's expand the attach timeline. And now we have to set the location, the rotation of our media plate in the detail panel to 0. Now the position of our media plate is the same of our 3D camera. Now we can move the position of our media plate using the gizmo in order to match the edges of our media plate to the edges of our 3D camera aspect ratio. In this case, as you can see, the aspect ratio of our 3D camera is different from our media plate. So let's open the detail panel of our 3D camera and let's search crop. And in this case, I will set my crop to 16:9. As you can see now, the edges of our media plate match perfectly with our 3D camera. Now I will adjust a little bit. Okay. I also suggest you to check if our media plate animation begins in the same frame of our 3D camera animation. In this case, I have to change by 1 frame the begins of my media plate animation. Now let's press play on our sequence. And as you can see, the 3D camera movement matched perfectly with the real camera movement. And in the preview, the movement of my subject looks really real. In my case, I already set the right position for my camera, so I will switch to my final 3D camera position. But don't worry, you can choose every position for your camera inside of Unreal. You can also decide to set another area of the viewport and create your personal render. This is the final position of my 3D camera. From the old 3D camera that you see before, I simply change the color temperature inside of the detail panel of the 3D camera. I suggest you to set the same temperature if you are using this camera in this area of the environment. As you can see, the position of my camera is almost the same that you see before. In this case, I simply check if my subject don't walk outside the bridge. I also remind you to create a camera cut inside of your level sequence and set the camera that we are using now inside of our viewport. Now I want to improve the pre-visualization of my media plate. I don't want to see all the elements of the set as the light, as the dark areas of my set. I just want to see my subject. So we can simply adjust the material distance of the media plate. Let's check the crop settings and set the crop values of our media plate in order to see only the subject. Okay, save it. And as you can see, we removed all the elements that we don't need inside of our viewport. If you want, you can also use a animated garbage mask and import it inside of the material distance, but I never use it, and I think is a waste of time create a alpha animation just to have a preview inside of Unreal. But if you want, you can create it. And now we have to adjust our sequence in order to export it inside of the movie render queue. You have to know that we will render two sequences for our composite workflow. The first with the environment, as you can see in this moment, and another sequence with only the fog inside of it. And inside of this sequence, we also deactivate all the lighting. Now let's set this sequence, and the only thing that I want to do now is to deactivate the post-process volume inside of my sequence. So inside the outliner, let's find the post-process value global and drag it inside of our level sequence. Now press on the plus icon and click on Actor Hidden in Game. And now let's deactivate the visibility. Now we will deactivate the visibility of our post-process volume only for the render of this sequence. If you want to deactivate the post-process volume in another sequence, we have to repeat this process again. Obviously, we want also deactivate the visibility of our media plate and our geocard. So in the detail panel of our media plate, let's search hidden and let's press on Actor Hidden in Game. In this way, our media plate will be invisible for all the sequence inside of our project. I suggest you also to repeat this process for the geocard. Obviously, you can decide also to deactivate the media plate and the geocard only inside of the sequencer. Now let's add our sequence inside of the movie render queue, clicking on the check icon. And now we will to duplicate our sequence inside of our content browser. Ctrl C and Ctrl V. And now let's also change the name of our new sequence, and I will add a suffix fog. Now let's open our new sequence. As you can see, this is the same sequence that we created before. Now I want to add a fog inside of my level sequence. Obviously, in my case, I created before the fog inside of my environment, but I will show you how to create it by ourselves. In this case, with the all light activated, the fog is almost invisible, but we have to deactivate all the lighting in order to see better our fog inside of our viewport. Now I will show you how to add the fog inside of our environment. Before, I want to explain you what is the heterogeneous volume. The heterogeneous volume is simply a 3D asset that contains a specified material that will generate a 3D fog inside of our environment and not a simply 2D plane fog that are common inside of Unreal. First, we have to add inside of our project a VDB file. In my case, I have the VDB file already in my project, but you can download it in the folder below of this video, and I will also give you a guide to add all the elements inside of your project. Now I will show you to import a VDB. So let's drag the VDB file inside of our content browser. And now you will see the Open VDB Importer option. You have simply click on Import. Quite simple. Now let's open the master material of the VDB. Now from the place actor, let's add inside of our environment the heterogeneous volume. By default, our heterogeneous volume will be invisible. That's because there is no material inside of it applied. Now let's open our master material VDB that you can find in the mega folder in the below of this video. And as you can see, this is a quite complicated material. You don't have to change anything inside of this material. You will need only to set the sparse volume texture sample parameter. And in the detail panel of this node, you have to add the VDB file inside of the sparse volume texture. Obviously, by default, this sparse volume texture will be without any element inside of it. So it's normal if you see this error alert on the sparse volume texture sample parameter node. Now, after you set the volume texture, let's save your master material and return on the content browser. As usual, you have to create a new material instance. In this case, I will call it mmvdb tutorial. And now let's drag our material instance in the detail material slot of our heterogeneous volume. It's normal if you see your fog completely black, you need only to adjust the material instance. So let's open and activate the VDB BB density and the VDB density. Now you have to decrease this value. I suggest you to copy my same settings to achieve the correct result. And now inside of the environment, as you can see, our VDB is almost disappear. There is the fog, but with the lighting activated, we can see it in a proper way. So now we will deactivate all the lighting inside of our sequence. So let's open our sequencer and let's import all the elements that we want to hide inside of our viewport. I suggest you to create a folder inside of your sequencer to organize better your elements. I call this folder lighting. And let's start with importing inside of our sequencer the global lightnings elements. So the directional light, the exponential light fog, the atmosphere, and the skylight. Obviously, the post-process volume is already imported inside of our sequencer. And now let's deactivate the visibility from one of these assets. And now, deactivating the visibility, we can copy the settings and paste for all the others assets. Now we have to deactivate the lighting from the artificial lights that we see in our viewport. Don't worry, you don't need to deactivate manually each single point light. You can simply press on one of these lights on the wall. And see inside of the outliner the folder which contains all of these lights. Now let's select all the lights inside of this folder, in this case Chasm lights, and let's drag inside of the lighting folder. Now I suggest you to expand the sequencer tab and copy the visibility and paste it, selecting all the lights that we imported before. Ctrl V, and as you can see now we deactivate all the lighting on our viewport. If you need, you can also use the unlit mode on the viewport 1 in order to see better your environment also without the lighting activated. So let's choose unlit. Okay, now I have a really better visualization of my 3D environment, but I can see my heterogeneous volume. To see our heterogeneous volume inside of the viewport, we have to use the light channels of Unreal. So let's search our heterogeneous volume in the outliner, and in the details, let's search for channels. as you can see, we have the lighting channels, and we will set our lighting channel to channel 2, because I'm sure that my environment it will set by default to 0 or 1. Now all the light set to the channel 2 will affect my heterogeneous volume. So let's add a new point light from our place actor. And let's deactivate the 0 channel on our point light and activate the channel 2. Let's increase the intensity of our point light. Now I will increase the attenuation radius, the source radius, and the soft source radius. And now I will find a good position for my light. In this case, my point light is not affecting the world. So I have to set my intensity value to a higher value using the EV channel. Now let's start setting the intensity to 15. But in my 3D camera, I can't see any changes. So let's increase our value to 20. And now I can finally see my fog inside of my 3D camera. Now I will increase also the attenuation radius and the source radius. Now let's find again a good position for our point light. As you can see, the look of my fog changed a lot, changing also the position of the point light. In this case, I prefer to set the position of my light under the bridge, simply because personally I like the look of the fog with the position of the point light, but you can choose whatever position you want for your point light. Now let's change the position also of the heterogeneous volume. Okay, I think is okay. Now our fog is finally visible inside of our viewport. Don't worry if you also see the shapes of the 3D element inside of your 3D camera. We will fix this in Nuke after. Now we can finally add our sequence inside of our movie render queue. But before to render, we have to add some element inside of our project. If you followed the guide in the folder below of this video, maybe you imported this element. However, I will show you the process. So let's open our content browser and clicking on the content folder, right click and click on show in Explorer. In this way, we will see the original folder of our content browser. Now I will add my element inside of my content folder. So now I will create another folder called import. Press OK. Let's open the import folder. And now I will simply drag my elements inside of my import folder. And now if you check the content browser, we can see the import folder with the elements that we imported before. In this case, I don't want my MMVDB master material. As I said before, I suggest you to set a specific folder only for the VDB. Now let's set our OCIO ACES. Let's open. And on the configuration file, we have to set the ACES file that I give you in the mega folder. Now on these rated color spaces, let's add two array elements. In the first, set your index to utility linear rec 709 sRGB. And on the second index, set ACES CG. Now save and close it. before to render, I have to remind you to open the first level sequence that we created before and add inside of it the heterogeneous volume and the point light and deactivate the visibility for each of them. Now we are ready to set our movie render queue and render our sequences. So let's click on Unsaved Config and let's open the configuration settings of our sequence. Now let's press again on the Unsaved Config and choose the preset that I created for you. In this case, this is the sequence with the lighting activated, and I will choose UFF EXR AOV's render. Click on yes. Now check if the color output is set in the proper way. With the OCIO configuration source activated, with the transform source set to linear rec sRGB, and the transform destination to ACES CG. And also you have to disable the tone curve on your color output. Now you can set the output of your render and choose the directory which you want to export your sequence. In this case, I will also add a prefix to my sequence, AOVs underscore. I suggest to create a specific folder for the AOVs because it's a EXR sequence, so you will export a lot of frames with a single render. Now let's set the second sequence on our movie render queue and use the JPEG render preset. Let's press yes. As before, check your color output and set your output. In this case, I will add a prefix fog underscore, and I suggest you to create another folder close to the AOVs folder that we will export with the previous sequence. Now let's accept. Now I will select each of my sequence and I will press render. Once our render will be complete, we can go back to Nuke for the composite process.